other questions we can ask here. Probability student is male if they are in nursing. Question mark. Question number 1 in this one. And I'm going to ask a similar but different question. Probability student is in nursing if they are male. All right, so think about those two questions for a second and see if you can come up with a fraction, percent, or decimal to answer each of those questions. And feel free to keep it to yourself. If you want to put it in the chat, that's always cool too. All right, so I'm going to take a look at the first one here. So probability a student is male if they are in nursing. All right, so probability a student is male if they're a nursing student. So that if they're a nursing student, that kind of changes everything, right? The probability a student is male, well, that's just 2 out of 100. Now they're in nursing, so that's just still these 2 here, but 2 out of what? So it turns out this knowledge becomes our new universe. So all I care about there are the students that are male and in nursing. And that makes sense, right? I'm talking about males, I'm talking about nursing, so that 2 should be important. So there's the males and in nursing. But now it's just out of the nursing students. So I count up these guys here, count up those guys there. So I have 2 males in nursing out of 10 nursing students total, which I could also state as 20%. So 20% of nursing students are male, is what this probability is talking about. Looking at the other one, nursing students, okay, if they are male, right? So that if changes everything. So I only want to talk about the nursing students if they are male. So the green one, that first question I asked, that basically targeted the nursing students. Now I'm changing course here. I'm only targeting the male students this time. So the question heads that way. So it's not out of the total now. So another way I could write this down, that would be the probability someone is in nursing and is male out of the probability they're male. And we can either look at that as counts or percents. So like before, I was just looking at counts, 2 out of 10. So here I could just say that's 2 out of 45. If I think about it in terms of probability for a second, the probability someone's nursing and male, that's 2 out of 100. That's my numerator. My denominator would be the probability of being male. Well, that would be 45 out of 100. And that dividing by 100 top and bottom, that divides itself out, leaving the 2 out of 45. Now that's a little messier decimal. So just some ideas about playing with percentages. If on my calculator, I say, okay, what is 2 out of 45, calculator? Calculator says it's 0.444444, and those fours go on forever, which is an awful nuisance. So the question is, where do we round? And the answer is, well, it depends. So what I usually do is if it comes out to, you know, near some whole percentage. So this one was 0.444, and the fours just kept going, dot, dot, dot. I would usually rewrite that as a percentage, so shift the decimal twice. So I would say that's about 4.4%. So in this case, I'm choosing to go to the nearest 1/10 of a percent. So I go to the nearest 1/10 of a percent if it's a reasonable thing to do. If we had a calculation and it ended up being much smaller than 1/10 of a percent, then I might want to show more decimal places. So we just kind of take it as a come, but 1/10 of a percent is a good start on a rounding rule for working with probabilities. If that 1/10 of a percent comes up with 0, then we might want to consider looking at further decimal points. All right, so let's see. We are going to take a look at some similar things to this. These new, just similar examples to this one right here. These kinds of probabilities that I'm working on here where the denominator is no longer the total, this is like the big idea for the week. These are called conditional probabilities. And the idea of conditional probabilities, a few things. Some additional information changes the denominator. Right, so that additional information was if they were nursing over here, if they were male. And that gave us a denominator of 10 here and 45 there, instead of the 100 for the whole group. So that's one big consideration for a conditional probability. The other big idea for a conditional probability is just when we're focusing on a subgroup. And I think the majority of the time we see statistics like 1 in 5 women deaths are because of heart disease. That's a conditional probability, right? It's the probability on a condition that you're female who died. We're not talking about males there. It's slightly different for males. And the notation for the conditional probabilities, again, shorthand, is we have some situation or event A if this other situation arises or is related. So if, you'll see there, sometimes instead of if, it would be something like A knowing B. So sometimes you see the word knowing. So what's the probability a student is male? Instead of if, I could write knowing they are a nursing student. That's another slight language change. Either way, calculating that, we want to know, okay, look at where they overlap, A and B, and then divide that by that new information, that change in denominator there. So this is the idea of a conditional probability. And there's several reasons I think conditional probabilities are important. One, when we see these probabilities in news media, it's often a conditional probability. It's a probability based on a subgroup, not on the whole population. And two, in certain kinds of testing situations, like testing for COVID, testing for breast cancer, testing for colon cancer, testing for any kind of cancer, there are false positives and false negatives. And those false positives and false negatives are conditional probabilities, and I want to talk about those this week. So false positives, positive test results, and false results. Negative test results are conditional probabilities. And so that's what we're going to take a look at next.